Hello and welcome to the Faculty of Engineering and Design's virtual tour. This unit will cover the lab spaces used for the Department of Civil and Environmental Engineering, which includes civil, environmental, and architectural conservation and sustainability engineering. This tour was developed by students and researchers of Carleton University in collaboration with the Faculty of Engineering and Design and the Carleton Immersive Media Studio, or CIMS team. During our tour, we will walk through campus, enter labs, discuss the equipment, and hear from current students about their experience. Each of our destinations will be marked with a red sphere and have been captured within a 360-degree photosphere, which enables you to pan around the three-dimensional space. During our transitions from room to room, I encourage you to ask any questions you have about engineering and design at Carleton. Now let's get started. Our first stop is the Academic Support Office, found on the main floor of the Minto Center for Advanced Studies in Engineering. Probably been receiving a lot of emails from our Engineering Academic Support Office, or the ASO for short. The ASO team is here to assist engineering students with course selection, registration, learning resources, and extra support. They are available to help you from your first year all the way through to graduation. All ASO services are currently being delivered remotely, but the team is always just an email away. Erin, could you tell us about your experience with the Academic Support Office?
The academic support office was there to help me create a schedule that worked for my needs and really made sure I felt ready for my first year in engineering.
Now back to the main floor. This lab is used by second, third, and fourth year Arch-Eng, Enviro, and Civil Engineering students. The test facility is 11 meters high and has 3,000 square feet of floor space. If you look up, you will see a crane used to move heavy equipment around the room. This room is also equipped with a strong floor that is 1 meter thick. If you look down, you will see circular discs that can be removed from the floor. There are approximately 600 holes in the floor to allow us to test different structures. Test beams can be secured to the floor through these openings. The foundation of this area is also separate from the rest of the building around us, so test vibrations do not impact the structure. MTS loading machines can perform compression and elongation analysis to samples rather than an entire structure at variable speeds, as stresses produce different results at different speeds. Tensile, compressive, and cyclic load testing is done using hydraulics wired to an Ethernet analysis, which can simulate year-long experiments in shorter times. Students will have the opportunity to learn how to use surveying equipment and will make their own concrete beams to be tested for shear strength. Now let's hear from Cole. Could you tell us a bit about your experience in this lab and what equipment you've used?
Yeah, so I've had a lot of experiences in this lab. One specific memory I have is a lab we did where we were able to mix our own concrete and we made cylinders out of that. We did a slump test and we were able to take that and then test that concrete after it's set. And then we were able to test it in the hydraulic press and then do an analysis on the results. We also got to use a lot of the surveying equipment, including laser scanners and total stations. And we got to take a look at different elevations and then again take those findings and then create a lab report and submit our findings to the professor.
We're now in the basement of the Minto building. This lab is essentially a chemistry lab for environmental engineering students to understand the chemical, biological, and physical processes involved in cleaning air, water, and soil. Students will take river water and separate its contaminants using chemical physical processes, or treatment using UV light. Wastewater treatment is done by using microorganisms to break down the contaminants in the wastewater. The materials that settle out form a sludge that can be degraded anaerobically to produce methane and energy. Air quality is measured and analyzed using an air sample from the roof of this building. Fourth-year projects include designing systems to clean air and water, cleaning up contaminated sites, gas stations, LeBreton Flats, evaluating waste management alternatives and waste to energy, designing systems to reduce greenhouse gases, and improving air quality and conserving water.
This lab is used to teach third-year environmental engineering students the fundamentals of soil behavior and geotechnical mechanics. This geotechnical lab is equipped with testing equipment including automatic shakers for sieve analysis, Atterberg devices, Proctor instruments, odometers, direct shear machines, and a triaxial test device. In this lab, students conduct 7 different tests including sieve analysis, Atterberg testing, standard and modified Proctor tests, hydraulic conductivity measurements, consolidation tests, and finally direct, shear, and triaxial tests. Students will work in pairs to complete the lab with the assistance of teachers' assistants and/or professors. The Elsie McGill Learning Center, EMLC, is focused on furthering students' understanding and comprehension in their engineering studies and provides students with the academic support they need to achieve their learning goals. The EMLC operates using a peer tutoring model to offer academic support to first-year engineering students. Peer tutors, who we call scholars, are hired and trained to assist you in your learning, whether you have a quick question, want to review a solution, or just need a fresh explanation of content that was covered in class. Our engineering scholars are here to help with your first-year engineering courses. And while the EMLC can't be delivering in-person services this fall, they will be available through a new online tutoring platform. Imran, can you tell us about your experience with the Elsie McGill Learning Center?
Yeah, for sure. I used the Elsie McGill Learning Center a couple times through my undergraduate degree, especially in my first year. The Elsie McGill Learning Center was extremely helpful in helping me review topics before midterms and final exams to make sure I had all my bases covered, as well as just to make sure I had a more thorough understanding of all the course material.
We are now going to head to Mackenzie Building. Although both buildings are connected, it's nice to walk outside through the engineering quad where there's picnic tables, benches, and summer study spots. In the winter, students often opt to keep warm by using our heated underground tunnel system that can connect you to any building on campus. Now let's head inside. Both second and third year students use this lab to understand the fundamentals of thermodynamics and heat transfer by analyzing gasoline engines, diesel engines, gas calorimetry, and carrier air conditioning systems. These engine tests are done to determine power, emissions, and engine efficiency. This mini cooling tower experiment is used to understand how superheated water with debris is transformed to clean cold water. This lab is set up very similarly to the solid mechanics lab. 2 teachers' assistants will assist groups of 2 to 4 students complete the lab within the 3-hour period. Imran, can you tell us your favorite experiment in this lab?
My favorite experiment performed in this lab was the engine test lab. In this lab, we used data on specific fuel consumption for each engine over a given time period and analyzed how much horsepower each engine put out. We were able to find the efficiency of the engine and make some conclusions about the engines themselves.
Third and fourth year students use this lab to understand aspects of aerodynamics using fluid dynamics. This channel is used to study high angle of attack flows dominated by flow separation and for rotary wing wake analysis. Using a dyed water channel for these tests allows for accurate testing of small-scale models while producing excellent flow visualization, which helps researchers understand airflow behavior. Imran, how did you use this lab?
In one of my fluid mechanics courses, we used a separate water channel in the same laboratory to do an analysis for a phenomenon known as hydraulic jump. This is truly one of my favorite labs that we did in my undergraduate degree.
We're now headed to the 3rd floor in the Mackenzie building. You're currently in the office space for the Carleton Student Engineering Society, or CSES for short. All students are members of CSES and have access to many of their services like textbook trades, networking nights, social events, and much more. Dency, who is currently the VP of Finance, is going to be talking a little bit more about what the CSES office does.
CSES offers academic events and social events to all of the Carleton engineering community, such as the Carleton Engineering Competition and Trivia Nights. They also offer conferences where engineering students can go meet students from other universities. CSES also offers funding for clubs and societies and for 4th year projects.
The 3300 block is unique to the engineering building. This block is dedicated to our engineering clubs and societies. There's stream-specific societies like CIMS and SRESOC, and engineering clubs like EWB, CU in Space, and many more. This area is also home to Leo's Lounge, which is completely volunteer-run. It's also the cheapest spot on campus to grab a coffee or snack before class, or if you're just looking to hang out, play some games, and make new friends. Nancy's going to talk a little bit about her time involved in the Carleton engineering community.
I've been part of CMAS and Q for the past few years. Q is the Carleton University Enterprise, where I was finance director. At CMAS, I started off as a first-year rep and then made my way up to be a finance director. I was also a cast member in Michael Mia. Sound familiar? That's because the Carleton Engineering Musical puts on 2 parody shows every year. I was also part of EngFrosh, which is the fall orientation program geared towards the engineering and design students. I started off as a frosh, then a facil, and now I've been planning member for 2 years. I would highly recommend students to get involved in the CEng community. It helps you make meaningful connections and develop skills that you don't learn in class.
This lab introduces all first-year engineering students to electrical circuits and mechatronics. Students are introduced to DC and AC circuit behavior and electrical measurements using waveform generators, oscilloscopes, and multimeters. Students are introduced to digital systems based on the Raspberry Pi single-board computer. Python coding is used to enable sensor measurements as well as control of displays and actuators through the general-purpose input-output GPIO pins. Students work in multidisciplinary groups to complete a mechatronics project. Now let's hear from Erin about her experience in this lab.
The mechatronics lab was my first real hands-on engineering experience. Before then, I had never touched a breadboard, let alone a Raspberry Pi, and being able to use them both with my new coding knowledge to design my own project was absolutely amazing. It can really confirm for me that I wanted to be in engineering.
This fall, lab stations will be remotely accessed from outside the university. Students are able to control the generator and oscilloscope or remotely program the Raspberry Pi and observe the results through a webcam. TAs will be available in the lab and by phone or Zoom to help students through their experiments. This is the Northern Nomad Tiny House. It's 220 square feet and has 12-foot ceilings. It was a fourth-year capstone project for students in civil and architectural conservation and sustainability engineering that began in fall of 2016. It is intended to be a net zero energy building, meaning that in a calendar year it produces as much energy as it consumes. It is able to operate both connected or disconnected from the grid and is insulated using highly efficient vacuum insulated panels usually found in refrigeration equipment. Students were able to design and build this tiny home and present their findings to industry partners. We have now reached the end of our tour. Thank you for joining us today. If you have any questions, please feel free to ask them now or email us at engineeringoutreach@carleton.ca. Best of luck, and I hope to see you around.